Hey guys, and welcome to the second part of the Material Editor Devlog. If you haven't watched the first part yet, be sure to do that first so that you have a better idea of what we're doing here. So the application that you're looking at right now should be pretty familiar to you from the previous part, and it looks almost exactly the same as it did in the previous part. And indeed, I haven't done many visual changes to the editor since the previous part, but more so on the code and the technical side. So let's have a look at that today. And it's been almost exactly 2 days since I recorded the previous video. So I've had 2 days now to work on this, and I think it's a pretty good time to take a break and show you where I am and how things are going. Let's look at what we are dealing with here. I'm going to turn the magnet on like that. First of all, I've added some node types here that I imagine will be handy for a material and shader editor like this. So these are sort of considered testing nodes, but they might very well actually turn out to be early versions of the final nodes. But we'll see. So here you have, for example, a vector operation. It takes 2 vectors as input and returns another vector as an output, and you can set the operation to perform, etc. Here we have a float operation, which has slightly different operations to choose from, accepts 2 floats and outputs a vector. And you can see these are different colors, these pins, and that specifies the type, and we'll get into that a little later, what that actually means, and some repercussions of having different types. You can also connect things together, but you can't connect different types together. That is disallowed by design. So all of this looks pretty similar to what we had in the previous one. The difference is that this view now actually communicates with the rest of the editor, while in the previous video it was just sort of sitting there. And if you're wondering what this editor actually is, this is a node editor component called ST-Node Editor, which you can find on GitHub. Links in the description of the previous video if you want to check that out. I've had to make some small changes to it to work better with how this editor expects it to work, but that's the beauty of open source software, that you can go in and actually poke at things and make them work how you want. Okay, so for the past 2 days I've been working on what you might call the editor architecture of this application. So what does that mean? Well, it's kind of tempting when you start working on an application like this to simply load your document, which in this case is a material, into memory, and then start adding all these buttons and drop downs and whatnot, and have them poke at the data. And then when you're done, you save it out to disk, and Bob's your uncle, as they say. And that works. That's definitely a way you can create editors, and some of the editors I have created for this game engine work exactly like that. But that tends to lead to pretty messy code, and code that is hard to make changes and improvements to in the future. So it's better if you think a little bit about the editor architecture that you want for the application before you actually start poking at the data. And I've found, for myself personally, this may not apply to everyone, but I've found that a pretty good way to make sure you're sticking to an architecture is to actually introduce undo and redo support. And that of course refers to if you have a node, you add another node, then you move that around, and then you connect a pin, for example, then you can go and undo all of those changes, and you can even bring them back later by redoing all of this. And you can see here that every modification, even the selection of nodes, is handled through commands. So here when I go back and forth, it actually does select this one because apparently I clicked that. And this is not something that the ST node editor component gives you out of the box. This is something that you have to add yourself. And if you want undo redo support, that's something that you definitely should put in from the very beginning. It can be done retroactively, but it becomes much harder, and in many cases it's just not worth it. It's easier to just rewrite the whole application. But I'm sure it can be done, and probably has been done. But if you do it from the very start, then not only do you get undo redo support, but you also sort of you enforce yourself to work according to a certain like paradigm, and you have to have a certain discipline to make things work. And so it makes adding features slightly slower in the beginning, but over time it will hopefully make things much easier. And if we actually just restart the application like this, you can see how it works in this editor. So I drag the editor log here off to the side so that we can see, we can make it a bit taller without obscuring the view. So it says here that when we started the application, it says executed command create new material, and the editor creates a new material. If you don't open a material with it, you just open up the application, it creates a blank material for you to start adding things to here. So we can drag some nodes here like this, and for every node that we drag, it has executed another command. So add shader graph node, and then the type of the node. And so if we now undo, you can see that it writes that it undid the command add shader graph node texture resource, which is actually the same one that it just executed. And that should give you an idea of how this undo redo system works in this engine, this application. If we add a sample texture node here and we add a connection between them, you can see that adding shader graph pin connections is also handled through commands, and you can undo those, and you can move nodes around like this many times, and you can then undo those movements and redo them, and all of that. And so the rule of thumb here is that every modification to the data, which is the material document in this case, needs to be handled through a command. That's the only way you can make actual changes to the data. And we actually do some things that don't even touch the data through commands, such as selecting objects like this. They don't actually touch the data, but they're still handled through commands, so that we can undo and redo them. Okay, so let's have a look at how this works on the code side. And I should mention that this is not the only way to do undo redo support. Another way that some editors use is to simply store a snapshot of the whole state in memory every time you make a change, and then if you want to go back, you can simply go back to that snapshot and reload it from memory. And I'm sure that can be quite handy, because once you have the system set up, it should essentially cover everything. But the command system is something that I use in the level editor for the Basis game engine, and I have some experience with, so I chose to go with that. It's by no means the only way to add undo redo support, and I'm sure there are other ways beside these two as well. Oh, actually, before we look at the command system, let's have a quick look at another thing that's quite important to this to this editor. So if we have these two nodes here, and I move this node here, you can see when I let go of the mouse, it will tell me that it executed the command move shader graph nodes. And then I can undo it and it goes back, right? So another important part of the architecture in this application is the fact that data is stored in two locations. So we have this view here, and it has two nodes. And these nodes are what I call the UI nodes. There are also the so-called data nodes. And whenever you create a new node like this and you drag it in, the component, the ST node editor component, creates a new node, like voila, and we get the new node here. And that in turn triggers a command which creates the data component. And the data components use my own node graph library rather than the ST node editor library. And there are multiple reasons for that. First of all, when the output of this material editor gets shipped off to wherever it goes, most likely a material converter, that material converter doesn't need to know anything about what this node graph looked visually. It just needs to know which nodes were connected to which nodes and their data and types. So it's kind of unnecessary to have this whole WinForms node graph library here in the converter, and so that's why that's one reason why when you move something around, the object moves here as I'm dragging the mouse around, yes, but whenever we actually execute the command, the change that was made to this UI node gets applied in the data through a command. And another reason why that is very handy is that if we take a look at the command that moves shader graph nodes around, I can make the code a little larger so that you can see it easily. So we have a class here called move shader graphs nodes command, and it derives from a very basic material editor command, which all commands need to. They can have an execute and an undo. This undo is optional, and then some properties here. But this command accepts a number of node movements, and a node movement is essentially just it has a node, it has an old location and a new location, and whenever you move something around, that means that to be able to revert that movement, you need to know what was the previous location. So if I now press Ctrl Z, it jumps back to where it was. Same thing here, it jumps back to where it was. And the move shader graph nodes command is triggered when I let go of the mouse, which is now, and you can see it executed here. And that means that it's kind of handy to have two versions of this, because in many cases when you make a change, you have the current or new state, which is reflected in these editor nodes like this, and when the command was run, you also have the previous state, which is in the data version of that node. So that way you can use those two to populate these commands, and then when they are executed, they actually go in and poke at the data nodes. And so here you have, for example, if we go back to this move command, you get the node graph, which is this is the data node graph. So it gets it from the current document, and current node graph, like obviously we have like many render passes, and they each have their own shader stages, so there can probably be more than one node graph in the material. So current node graph, and we hold on to the movements, and we get the editor for the UI nodes, which you can just get from the first node's owner. And in the execute, we for every movement we get the node, and out of that node we get the material node, which is like that is the node that lives in the data. So the data node is another word for that. And then we move the data node like this. So when we move this around, now that I let go of the mouse, this execute function takes the position of this node and puts it in the material node. And of course, if we're redoing the command, then we also need to apply it to m.node, which was the UI node. So if I undo this and I now press, we can press it even here, redo, it jumps back. So we need to apply it to both this UI node and the data node, if that makes sense. And undo is perhaps a little easier because it just takes, again, it gets the material node from the UI node, it sets the old location, and then it sets the old location on the UI node. I hope my explanation came through all right, but the main thing to keep in mind here is just that the data is stored in two different places. You have one version which is the view here, and one which is in the document or the data, and that version is only allowed to be modified through commands. And that makes perfect sense, essentially, because if you're thinking about you're dragging this around, you're modifying the state all the time, and no commands are executed for this when I drag this around like this. And indeed, you don't want them to. You don't want like a command to be executed for every single 1 pixel movement that you drag this around. Only when you stop. And now if you undo, it should go back to the state that it was before I started that crazy movement, which was there. Right, so that already gave us a pretty good idea of the command system in action. And again, this is perhaps not the best way to do undo redo, but it's one way. And depending on the command, this is a pretty easy command still. You have to be careful when you're writing these that you're executing something. You're essentially producing a diff, applying a delta to the data, and you need to be careful that when you undo that, you need to undo that delta to get back to where you were before, and that can get a little tricky depending on the command. But other than that, it's quite nice because these commands don't take up that much memory. Right. So let's talk a little bit about the type safety. That's another thing that I've had to like scratch my head a little bit. So if we have a look at, well, maybe we can have a look at this float op node. So we go here to float math nodes, and this is the UI side of the float op node. So it has some empty lines here, which essentially just pushes these two input pins down a little bit. Yeah, the ST node editor calls these options, but I tend to call them pins, sort of from electronics. So it has 3 input pins, 2 float input pins, and 1 output result pin, like this. And these round pins just means that you can only have a single thing connected to them. A square one means that it can be connected to multiple things. So if you have this square output pin here, can be connected, for example, to both of those at the same time. A round input pin can only be connected to one. So you can't do this, for example, because this input pin is already connected to this. But if we remove that, then now we can do it. But especially with vectors, it can be a little difficult somehow or sometimes to maintain 100% type safety in a shader graph like this, because if you have this sample texture node here, it takes a texture, and that's easy. Then we can just connect the texture to it like this. But this UV, well, this depends on the texture. Is this a 1D vector, or 2D, or 3D, or what is the type of this? And the way I've sort of handled this, at least for now, is to introduce something called a vector variant. So if you look at sample texture here, it is this class here. It has two input options, one texture pin type and one which is the UV, which is a vector variant. So it's this guy here. And a vector variant is essentially a vector that can be anything from 1 to 4 dimensions. So it's a struct that has 4 components and then one type ID, and depending on how you initialize it, it takes on a different type ID. And yes, I could use some fancy .NET type information here, but I like to use my my basis type system for this kind of stuff, because that will allow me to for example write the converter in C++ or something else if I want to still consume the same data. And that way these nodes can then be sort of intelligent about it and determine at sort of evaluation time, okay, what type is this UV actually? Is it a 2D sort of typical UV vector, or is it actually a UV W, like a 3D UV coordinate vector or whatnot? And you can still connect it like this. Some of these things are kind of maybe a little annoying, like the fact that you can't, for example, you can't connect this float here, like a dot product between two 3D vectors is a float. So one could think that you should perhaps be able to actually connect that float to this UV, because it could then use this input vector variant. And that's not currently possible because of how the type safety works in this node editor. Of course, I can always just add a new node here which takes a float and turns it into like a 1D vec variant, but yeah, I don't know. I'm not sure how I want to handle that, and remains to be seen how big of a problem it actually turns out to be. But yeah, this is the kind of thing that you have to like figure out especially when doing shader things, because the shader built-in functions tend to accept any kind of vector and not just like a 2D or 3D vector or whatnot. So you don't want to make specific nodes for every single vector type, but rather have it figure some of that out on your behalf, much like the shader compiler does when you're writing classical shader code. All right, I think that's pretty much it for now. I better get back to work and continue on. So the next thing would be to work a little bit more on showing the properties correctly, and perhaps even the render pass. I don't know, maybe the render pass will come later, but at least the node properties should be kind of first pass finished before moving on, and then on to actually saving and loading materials. And you might be thinking like, saving and loading, is that really relevant now? Shouldn't I just move on to the more interesting stuff, things like code generation? But I think in this case, saving and loading makes a lot of sense, because it's not terribly difficult to do. It's just usually quite a lot of work, and actually doing the difficult things like the code generation gets much nicer if you actually have a somewhat working base editor where you can create different testing node graphs and quickly make changes and save them and see the difference in the code generation and all that. So I think it makes sense to do that next. And that should also just allow me to slowly but surely expand this library of available nodes that I have, and make sure that it's kind of nice to just design these things, because in the end that is the whole reason why we're doing this, to make actually creating materials nicer than it currently is. But yes, I'm gonna end this video now. Please leave a like and a comment if you have any comments, questions. You know what to do, and I'll see you in the next one. Bye.